In this video, I'm going to show you how we can solve some divisibility riddles. And my first riddle here is write a 3-digit number that is divisible by 2, 5, and 9. First thing I'm going to do is I'm going to go ahead and make my 3-digit number. I don't know what's going to go in each place value, but I know it's going to have 3 digits. And then I'm going to think about what I know about divisibility rules. I know that if a number is divisible by 2, it must have a 0, 2, 4, 6, or 8 in its ones place, which would be this place right here. So I'm going to write 0, 2, 4, 6, or 8 underneath there. And I know that if a number is divisible by 5, it must have either a 0 or 5 in its ones place. So that eliminates the 8, the 6, the 4, and the 2. So that tells me the ones place must be a 0. The rule for 9 tells me that the sum of the digits must be divisible by 9. So that really means that if I take these, because I have a 0 in the ones place, if I take these 2 digits right here, they just need to add up to something that I can divide by 9. So numbers that I can divide by 9 are 9, 18, 27, and so on. But when I'm adding two one-digit numbers, there's no way I can get 27. Now I can get 18, but they would have to both be 9s. And I can get 9 in lots of different ways. I can get 9 by doing 8 plus 1, or 7 plus 2, and so on. 6 plus 3, 5 plus 4, and then in different orders. So there's lots of different numbers I can make here. I'm going to go ahead and just do 540, but I could have done 810, 720, 630, 990, 450, 360, 270, or 180. Let's look at another riddle. Our next riddle is write a number that is divisible by 3, 4, and 10. And I'm going to stick to a 3-digit number. And when I'm working these out, I usually look for whichever is the easiest divisibility rule and start from there. In this case, 10 is the easiest one because I know that any number that is divisible by 10 must have a 0 in the ones place. So therefore, this must be a 0. The next easiest one is probably the 4 because in the 4, I just need to look at the last 2 digits. And those last 2 digits must be divisible as a whole by 4. So I can start thinking about this. Now here are my options: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I put a 0 here, that would make this 100, and 100 is divisible by 4, so that would work. 10 is not, 20 is, 30 is not, 40 is, 50 is not, 60 is, you probably see a pattern here, 70 is not, and 80 is, and 90 is not. So I could put in this place value here, I could put a 0, 2, a 4, a 6, or an 8. Any of those will work because that would make the last 2 digits divisible by 4. Now I don't know which one I want to put there yet because I need to consider the 3. And the 3 says find the sum of the digits, and the sum of the digits must be divisible by 3. So I need to add all 3 of these numbers up, or these digits up, and they must be divisible by 3. So, a matter of fact, I can go ahead and put one of these ones from the 4 in there. I'm going to go ahead and put a 2. If I put a 2 there, the sum of the digits must be divisible by 3. So I can put a 1 here because 1 plus 2 plus 0 is 3, and 3 is divisible by 3. I could have also done, let's look at another example. I could have put, let's say, a 4 here. Then the sum of the digits must be divisible by 3. If I put a 5 here, 5 plus 4 plus 0 equals 9, and 9 is divisible by 3. I could have put, let's say, a 6 here. If I put a 6 here and then a 3 here, 3 plus 6 plus 0 is 9, and 9 is divisible by 3. So you get the idea, hopefully, that in a lot of these riddles, there's more than one answer that you can come up with. In this next riddle, we've added a little twist. We want to find a number that's divisible by both 2 and 3, but not by 10. Now, this seems complicated, but it really just means that the last digit cannot be a 0 because any numbers that are divisible by 10 end in a 0. So to be divisible by 2, it must end in a 2, 4, 6, 8, or 0, but we know it cannot be 0. And for a number to be divisible by 3, the sum of the digits must be divisible by 3. So I'm going to go ahead and just put a digit in the ones place. I'm going to put a 2. I know that that satisfies the condition of divisible by 2 and not by 10. So now I just need to make sure that these 3 digits add up to something that is divisible by 3. And I'm going to make that fairly easy. I know that 6 is divisible by 3, so I'm going to make these add up to 6. 3 plus 1 plus 2 is 6. So therefore, I've just found a number that is divisible by 2 and 3, but not by 10. In this example, we're looking for a number that is divisible by 3 and 9, but not by 5. I'll go ahead and make my 3 digits. And I know that this last digit cannot be a 0 or a 5, because the rule for divisibility by 5 is the ones place must be a 0 or 5. So it cannot be a 0 or 5. So I'm going to go ahead and just pick a number that will go in that place value, and I'm going to pick a 1. The rule for 3 and 9 is both has to do with the sum of the digits. So the rule for 3 says the sum of the digits must be divisible by 3, and the rule for 9 says the sum of the digits must be divisible by 9. So really what that just means is that the sum of the digits really just must be divisible by 9, because anything that's divisible by 9 will be divisible by 3. So I just want to make the sum of the digits equal a multiple of 9. The easiest way to do that would just be to add up to 9. 8 plus 0 plus 1 equals 9, and 9 is divisible by 9. Let's look at another example of this one right here. Let's say I put a 2 right here. And again, I want something that adds up to a multiple of 9. Let's say I wanted it to add up to 18, which is a multiple of 9, and that's also a multiple of 3. So it'll work for both conditions. It will make sure the number is divisible by both 3 and 9. We need this to add up to 18, so this could be something like 8 and 8, because 8 plus 8 plus 2 is 18.